Welcome. There we are. Welcome back. It's been a couple of weeks, I think, since the last stream, but I'm back now. Everything's cool. Everything's good. It's good to see you. So, on this stream, of course, if this is your first time tuning in, welcome. I think I've said that about 5 times now. I hope you feel it. Yeah, so, if this is your first time tuning in, I am Agent Ultra. I program mainly in Haskell these days, although I've been programming for a long time, and Haskell isn't not my first language and not my only language. But it's what we do here. And this project we're working on is called LambdaTrek. It's a procedurally generated roguelike inspired, Trek-inspired game about space ships blowing each other up, that kind of stuff. If it's your first time tuning in, let's show you what it looks like, and what we have so far, and what we're going to build next. We don't need PowerShell here. We're gonna... Right now it's a terminal-based application. But that may change in the future, depending on how far we want to take the project. I'm basing it off of our nice UI library called Brick. And I like Brick because it's very declarative. It lets you construct the UI very quickly and kind of just get going with stuff. Your main app. So it gives you a bunch of widgets and stuff out of the box, and you can just whip them together and have a little UI sitting in your terminal. So we run our package like this, LambdaTrek, on the lowercase though. And here's our game so far. Okay, we got like a little sector here. We're now procedurally generating bits of the game. Not well yet, but it's getting there. Got a couple of stars, we got some enemy ships. This S is your ship, that's the player ship. A $sign is a space station. Over here on the right hand side, we have the info panel. So it says the stats about your ship, what the current status of the shields are, the shield strength, how many torpedoes you have, so on and so forth. The goal of the game is to take out the enemy ships in all the quadrants, or all the sectors across the quadrant, before you run out of turns. So in this case, we're just kind of like chose an arbitrary number, 200. Maybe that should be configurable, I don't know, but there it is. You also have your command input area, so unlike more top-down roguelikes where it's all key-based, you just kind of the keys, these are like textual commands. And you can move around like that. And then we have the little handy-dandy dialogue area where you get kind of in-game dialogue about things that have happened in the simulation as they go along. And of course, we have our little quadrant map, which we've been working with a little bit now. And so you can warp to different sectors in the quadrant and continue explorations there. So there's quite a few commands implemented, quite a bit of work going into this. We're kind of working on the procedural generation side of things at the moment, trying to build up the game universe so we can start having more grand adventures. Yeah. Scale things up a little bit. Cool. So, yeah, flip over these with F keys. I'm just going to quit out here. And let's get going. Okay, so I believe our simulation state. So, one thing I might flip-flop on, I've been thinking about a little bit in the background between the last stream and this stream, as we've been doing this stuff, is if we go to the simulation, we go to quadrant and generate. That's where our quadrant generation is. We're generating a quadrant here. I was kind of getting frustrated with the fact that early on I'd chosen arrays to represent quadrants, because arrays are fixed in size, just like they are in C. Here. And when we're generating stuff, we're generating like one step at a time, and we're adding things to the quadrant as we go. And so I felt like a list was a better structure for that. And I don't want to flip-flop on this too much, but I was thinking in the background that, you know what, like we could still use arrays for the main quadrant data structure and just use the lists while we're building up and generating the quadrant. Because all we need to do to construct the arrays after we've built up the lists is like a simple call into the array library to convert the list into an array. One time, boom. Now we're back to arrays. But at the same time, why are arrays super useful? Well, obviously the fast indexing, right? O1 indexing into them to get your data. We're mostly doing sweeps over these, right? As we render the quadrant, or the sector, sorry. Or even as we do build a quadrant map too. When you're doing the scanning, you know, we're iterating over these things constantly. So either way, it's going to be like O1 every time. We're not doing a ton of like direct indexing. So lists might be fine, but I think that option is still there. And I was thinking basically we could create like a separate structure for the quadrant data. If I go up to quadrant here. So instead of we changed this from an array to a list of enemies. We could have it back as an array, and then we can have an intermediate like quadrant builder. Which would be basically this. But instead of arrays, it'd be all lists. We can even make these stars arrays as well. Quadrant builder like that. And then we would just need a function to go from, once we're done building the quadrant builder, it'd be like quadrant builder to build to quadrant. Something like that. And so that's what came to me during the week. I was like, we should probably do that maybe. But I think I'm going to keep that one in the back of the pocket. See how things go. Because if it's inconsequential to just use lists, then like why go through the effort, right? It's not a very big game with a ton of data. So let's get our builder going. Let's use our test runners as the builder. Let's see where we left off. So we clearly added enemies. And if we warp 2 other sectors, yeah, I think we get enemies here too. And some randomly generated enemies there. Yeah, I think we probably have enemies everywhere. Cool. Lots of stars. Probably too many stars. I was thinking that too. We might want to, like, as we're generating the stars, like, really condition the stars to be, like, maybe 2 at most for, like, a binary sector with binary stars. And that's the max. But we're just testing things out, so we'll smooth that out. Let's see now. Space stations? Enemy ships? Probably have proper constructors for these guys. Yeah, and so generate station is probably where we should go next. Looks like we're just adding 1 to every sector. Or we're using empty station array. So we're probably going to go through the conversion to list for stations as well. Quadrant. Let's go do that first. Station, like this. And that's going to break a bunch of stuff, so let's get back to green and back to building as quickly as we can. Starting in quadrant, yes. Got my type errors in here. Jump to the next one. Here. so we don't need list array anymore. Just pop that off, and that should fix that one. Next, stations prime. Right, so sector's probably expecting an array int of stations as well. Maybe ships. Okay, so we convert when we're building the sector here, and that's basically what we would do with the quadrant builder kind of idea. So we'll do stations. I don't know why I'm done with that. Seems like we should have more generic function there. That'll be array station. Let's just write it out anyway before we get too happy with that. If they're super similar, we'll just go ahead and fix that up. I mean, it's already, I think it's kind of obvious. But length, stations -1. And okay, so this should just be a list of A's to an array int of A. Yep. Zero, the length of x's -1, x's. Get rid of this one, it'll be the same. That means we can also get rid of this one and it will also be the same, so. For the win. Get rid of those. Wonderful. Next. Okay, couldn't... And so we got the same thing here. We expect an array. No, we expect a list. Getting an array. Because we're getting it from the sector. So to fix this, we do just as we did for the enemy ships. We just use the array's elements function to get the elements of the array out into a list. And we're good. For that module. And then we have to fix the simulation. So this effective, we don't need expected an array here. So we do a little bit of indexing. So to fix that one, I mean we can use array and we can do indexing on lists, it's just slow. But like I was saying at the beginning, these lists aren't very big. So the cost of doing that isn't very high. Well, we're calling elements here to turn it into a list. Oh, actually, I think we just need to get rid of the elements Sorry, I was getting confused. That's not the indexing operator I was thinking of. Oh, good, good. Next one. Up here and handle station collisions. Again. So we're converting to this to a list in a lot of places anyway. That, and that's all good. I think that might be Rebecca Green. Good. Let's just quickly check. Yep, looking good. Warp 1-1. You see there's still a station there showing up on the map. Okay, good. Yeah, I think everything's great there, so let's commit that. When this change is applied, we will change the station map, stations quadrant map type. Change it to a list type or easier lockdown. Okay, back to the project. Okay, so stations should be far more rare than everything else we've done so far. First, I think we should probably have a maximum number of stations, period, that we can place, and then we just have a certain chance of popping them into a particular sector. And we just keep going from sectors, rolling the dice, trying to place one until we've placed all of them. I think that's a pretty good strategy. So let's go into the generation state then. Stations. Packs. Align those like that, so then this will be our counter. And then our base case will be like when it's 0, stop trying to place stations. Let me see, what do we have? Turn random. Can I initiate that anywhere? Yeah. Yes, here. Engine in a quadrant. And we have to give it a number of stations to try and place. Let's hard code that to 2 for now. Move the maximum stations. Okay. So then we have to remember to add, generate stations. Okay. I think we've got all the pieces in place now. So let's see. Generate stations. Do we need to return anything? No. Let's update that. Oh, that's completely messed up. Perfect. Okay, so the next part then is to cycle through our sectors. Well, actually, we need another bit of state. We need the actual number we've placed so far. I don't know if we need to put it here, though. Okay. I don't know if we need to put it there. Because I think what we can do here is we can make that a parameter of our function. So, the first thing we need to do is to iterate over our sectors. Quadrants. I think we had that in the expression there. We do a bunch of stuff here. Do this, up here, there, with you, say, and this, okay. Okay. Put that. Put this. This little bit is what I wanted. Okay, quadricoids. That's what I was looking for. Okay, so what are we gonna do? We're gonna iterate over that. Until some condition is hit. Control the monad. How do we want to do this? We could... I want to repeat the action indefinitely. We're going to... What was it? The function cycle, I believe, will get me this indefinitely. Alright, so now this whole is a list of coordinates. Not quite what I want. Take 3 from that. Take 10. take 15. Okay, so that will loop over our coordinates indefinitely. So what I want to do is map over this list. Map M over this list, an action. Do I have that in Scoop, or do I have to import it? Yeah, board control.map. Throwing away the results. Okay. So now the shape of this function is about right. It's a coordinate to a state t function. So we can write that. Generate station. The sector coordinate. Okay. Sector chord. Get rid of the butt arrow. Now we're left with a nice little clean hole. It's just the state t. Okay, cool. So what I was thinking was that we would pass in the int of the current count as part of this function. But if we go with this approach, this kind of non-recursive approach, that's going to be a little bit different. I don't think this is the way to go. Because this map M is going to map over an infinite list. And we want to be able to terminate. So we're going to take the map M out. We're just going to go generate station. Or we will just do go generate stations. And we'll give it an initial count of 0. We haven't placed any yet. The type of this will become a list. And an int. Okay. Count. Station count. Sector cohorts. Okay, so now this hole is back to a state. That's good. So our base case is going to be if the station count is equal to the current state. So when it doesn't equal, well, we're going to need to pull the state out. We do stuff there. So, we called it generation state. Yet. Okay, so now in scope of that whole, the first one, we need an int. We've got generation stations max. Okay. So when the station count isn't equal to the generation stations max, then we're going to roll the dice. We're going to get this sector out of the quadrant map. we're going to roll the dice and try to see if we can place a station here. And if we can, we'll roll the dice again for a random coordinate in the sector that is empty. And then we'll place the station there. And we'll call ourselves again. Right. Otherwise, we just return. We're done. Yeah, so like, we're sort of inverting the base case here. Usually when I write recursive kind of functions, I tend to write the base case first and then the return right away at the beginning so that, you know, when you get to this case, you can just forget about it and exit early. But this pattern, you know, it's a thing. Welcome, Imluminson. How's it going? Hope I said that right. Have I done any programming in other functional languages? Yes. I first tried OCaml for a while. I did OCaml for a little bit. Yeah, I first tried OCaml for a while, and that was a long time, a while ago now, I guess. And then a friend of mine was really into Haskell, and so they talked about Haskell a lot, and I decided to try Haskell as well. And so I've been doing Haskell for probably about the same amount of time, actually. Maybe a little bit more. I do use Haskell at my day job, yeah. I was very fortunate to come across a job where I could use Haskell full time. Prior to that, I was working in a JavaScript shop, and for a number of years there. And functional languages were just something I experimented with. I did get to use Haskell for like some small little tools that I built for myself, but that's about it. Yeah, it is much harder to find jobs in functional languages, for sure. There aren't as many. The market isn't very big. As an applicant, this can be an advantage because, like, of a small pool, it's... I mean, the number of candidates you're going to be up against is going to be bigger. But at the same time, like... maybe it's harder. I don't know. Ooh. How's that going, Imlinson? I have much experience trying to use functional programming in like kind of mixed teams in these languages that are kind of somewhat multi-paradigm to varying degrees of success. How'd it go for you? When with station that, we're gonna get the sector out. Quadrants in there, yeah. Do we have map? The team has been learning and improving over the past few years. Code quality is much better compared to the past. I would hold weekly knowledge sharing sessions showing different techniques on how to utilize the code. Common similar API code reviews. Interesting, cool. And they've been receptive to this. It sounds like that's kind of nice. So when I've tried to do this with JavaScript teams, it's very mixed results because JavaScript's kind of like a lingua franca kind of language designed by committee, used in a lot of different contexts now, and suffers a little bit, I would say, from the tragedy of the commons by being so popular. So like, a very popular opinion in the JavaScript community is like functional programming is bad. And so there will be likely be people on a JavaScript team that think functional programming is terrible. Why would I do this in JavaScript code? It's going to make my code slow. These sorts of things. So it's been a struggle sometimes. Well, that's cool. That's a nice approach, and generally one I recommend too. I recently came across, I don't know if it was a blog post, but somebody was teaching. They were teaching monads in Ruby to a bunch of Ruby developers. And like the team was totally accepting of it. And we're like, why have not we been using this the whole time? I don't think maybe it was, I don't know if it was this blog post, but I think this is the library they were using. Dry monads. So, kind of neat. Yeah, not bad. I don't program in a lot of Ruby, but that's pretty understandable. Yeah, and a lot of those are all monads too. Yeah, that's so cool. I'm glad you've been having success with that, because like it's such a nice pattern. Cool. Yeah. So that's an interesting pattern to use too. Like there's a lot of situations where you don't need or you want to treat error cases not as exceptions, but as just like regular values, like failures. And some languages are starting to like build this into the language itself, like where you check some error result or some kind of convention like this. But I mean, I use them all the time on the stream. Pretty straightforward. So yeah, even coming to Ruby, people are like, hey man, this is good stuff. And in Java too. Nice. I like it. Yeah, I considered myself a functional programmer for a long time, but I've always kind of worked wherever wherever the job was, and wherever the interesting work was, and sometimes it's in C++, sometimes it's in Python, sometimes it's in whatever. But I've always had to struggle with like balancing how much functional programming you use in those languages, because some of them are not as amenable to the patterns for various reasons. And I think one of the nice things about moving to like a functional programming language that's designed for this kind of programming from the get-go is that you don't have to justify yourself when you join a Haskell team. Everybody's using functional programming from the beginning. Nice. But two, the language is designed for it at the outset, so like you don't have to worry about all the other stuff that you could use. It's just there. And so you get pretty good at functional programming pretty quickly when you use these languages, because it's the only way to do things. No escape hatches. Except maybe OCaml. And like, you could do that in Haskell. You could make escape hatches in Haskell and do like dynamic procedural programming in Haskell too, but you'd have to be pretty advanced at it. And it would look really weird. Maybe we should do that sometime on stream just for fun. Okay, so we got our generate stations function. We have to get the sector out of the quadrant data. Map. We can index into it with our coordinate, our station coordinate. Because we know that's going to be found. Yeah, so I think that goes generation quadrant. Map.bang. And vector coordinate. Oh, right. Right. Hang on. This isn't quite, the structure isn't quite here yet, because this is the list of these. We only want one at a time. Or at least I want only one at a time with coordinates. All I want to do is add the sector coordinate here. Maybe there's a... Is there a way to... Like, I know there's like sequence. We could sequence over it. But that would go infinitely as well. Although, I think what... So cycle is going to give us basically a lazily loaded list, right? So if we took the head of that list... Like, it was not empty, so we took the first element of it. That would be our sector coord. And then if we needed to recur, because we haven't placed a station, the rest should still be the rest of the cycle. Like, just unevaluated yet. So I think we should be able to do that. But since we decide this is a list at the type, we don't know that it's not empty. We do have to handle the base case where it could be empty. Or at least we have to prove to ourselves, maybe somewhere, that it isn't empty. Let's do that here, just as a sanity check. Not null. Sector coords. So we know, because we're reading the code here, that this can't be an empty list because of cycle. However, quadrant coords can still be the empty list, maybe. Right. So just as a little sanity check for ourselves, we can put the... It's not really proof, like Haskell doesn't know this is proof, but us here, so at least when we're reading the code, that, like, if it is empty, it's just going to go to this pure line. And then I don't feel too bad in here destructuring the head of the list and the rest. With sector coord. And then coords. It's not great to do that, but it's possible. Anyway, so we get the sector coord. That's pretty good so far. Why is pure throwing an error here? Parse error, possibly incorrect indentation. Oh, got a do here. And then we need some expression here. Oh, right, so this needs to be the actual map, so we gotta pull the sector quadrant out of that. And no, station map. Quadrant stations. There we go. Okay, so now we need to figure out whether we're going to place a station here or not. Get our gen random here. Returns an int. Would give gen random between. We could do 0 or 1. Either or. So we'll go station placement chance. Gen rand between. Gen random between. That's what I meant. Thank you, GHC. So helpful. So helpful. Okay. Let's see. So then, after we get the placement chance, we just check if station placement chance equals 1, something else. So if it's 1, we'll place a state. We'll try and place a station here, and place a station, and then we will recur. So generate stations with the station count increased by 1. And a sector cohorts, or rest cohorts, just cohorts. Yeah. No, I just gotta type that one in properly. Okay. Assuming place a station here. What do we need? PlayStation needs more information. Right. Can't be just state generation, state. Got to be the sector. It's got to know the sector it needs to place in. So let's put the sector chord there. Put it in here. And. So assuming that we can implement that. So we just go PlayStation there, then go generate stations again. Otherwise, we recur without increasing. Now, of course, it's possible, right here in this algorithm, that our random generator between returns 0 for a really long time before it finally turns 1. That's a perfectly valid result. So we might want to put a maximum number of attempts so that we don't get into this situation where it seems like the game is stuck generating in this stage. You know, and if we can't place all of them because our random generator is being weird, Or we could just abort. And we can abort and try again. Or we could just abort and give up. And say you don't get any this round. Ha ha ha. Good luck, player. Possible, possible. Okay, let's see. Banner match is not exhaustive. Yes, I know. Maybe. Actually, maybe I could do it this way. Get rid of that. Go stations. What about if this is empty? That's better. Because then this here can be... And then I can get rid of this. That was smarter. Then I don't even need that null check. That's better. I like that. So we don't use sector, so we gotta use it. So we should probably... Actually, we don't need sector chord, we just need the sector itself. No. No. We actually don't even need the sector. We just need the chord. Yeah, PlayStation should know enough from that, I think. Okay, so that's the basic structure there. Now we just have to implement place station. And then maybe go back or loop back around to the loop max, the timeout thing. Let's do this first. Sector chord. Bam, bam. Go. Let's get our generation state out. Actually, let's go one better. We'll get our sector straight out. We need the generation quadrant. And the quadrant station now. Yes, yes, yes. You think this is a hole because it's leading underscore. And it shouldn't be. Quadrant stations. That's why. There we go. Okay. So now we got the sector map inbound here. We can modify our quadrant. Actually, let's get the quadrant out. Okay. So we had some handy-dandy setter functions and stuff for this that we probably should implement now for stations. Oh, I think maybe it was in quadrant. Oh, yeah. Add star, add enemy, Add stations undefined here. Right, so it needs the sector coordinate, it needs the station we want to add, and the quadrant. Right, so we have the sector coordinate, we have the quadrant. We just have to construct a station for it. And quadrant. Now that is a maybe. And so we wrapped it up here. Add sector station. Very similar to this. Super similar. Yep. Add sector station. That's what we want. Okay, and then we just have to make the station. Our station code lives up here. It just needs a position, X and Y, and some energy. Okay, so we want to randomize the position, but it's been a while since we've tested the game, so let's just hard code a station here, and then we'll just test the placement. We'll do it at like 5, 4, 100 energy. And we're going to discard the results. Means we got to do this, or if I had a function called void. What's the problem with that? Oh, I'm having the quadrant indirectly. That's gonna do it. Okay, cool. Even better. Okay, I think that's gonna go to green now. Let's clean up these. Oh, almost. Undefined. Oh, yeah, because we haven't implemented that. So let's go implement that quickly. Okay, yeah, left it undefined. There you are. Okie dokie. So, this is our adding code to add stuff to the coordinates. So we wanted to maintain like an invariant for each sector that there's always at least a place to space, or a space to place a player, so that when they warp around, we could put them somewhere in the sector. It might be completely full and they'd have nowhere to move, but at least we can place them. So that's why I have these like setter functions here. I'm not super sure that like the API is great for it or whatever, but it's okay. We got our sector coord here, we got our station, and we get a quadrant. Our goal is to return a quadrant with maybe. So first we got to check the available space. Can we place a station here? Space in the quadrant or that sector. And if we can, Bob's your uncle. We can get a quadrant. Right, where are the quadrant stations? Is an adjustment. We stick the station on a list. And this is, if you've been in here from the beginning, this is why we switched everything over to using lists instead of arrays here. Just to make building easier. It's getting long. Otherwise, nothing. You can't place it. Don't even bother. Okay, there we go. So, the thing you might notice about this placement function is that it's just checking that there's space to place it there. Not that this is the coordinate you want to place it in. Like, the position of the station is a valid position for that station. We haven't verified that here, so... yeah, I don't know if we should put that on the caller, in order to keep this simple, and expect the caller to do that verification first. Or if we should do that here. Because if we do that here, that means the caller is just going to try it. And if it didn't work, it's going to have to, like, go back, try a new position for the station, and go there. And if that worked, no, right? Whereas if we try to assume that the caller is going to do their homework first, we're just going to add it here as long as this is true, and we're not going to overflow the space, then I think that invariant will still hold. But we still have that case. So we still have to be a little bit smart about our code and how we structure things here. Not sure how I feel about that one. I like it when I write functions where, like, things, you can only use it one way and it just works and you don't have to check any preconditions or do any of that stuff. It's just write by construction. But I don't always achieve it. Okay. So we have to look up, when we construct the station, we have to basically look up that thing from the available spaces. Choose a random one from the available spaces, and then call placement there. But let's just take a poke, see how the game's doing. Okay, so we got a starting station here. 2 of them, in fact. There's nothing in our algorithm that says that's not possible. So if we warp to 1, 1. Oh, we took some damage already because we warped next to an enemy ship. There's the station here. Oh, there might be some hard-coded stuff I left in. I need to get rid of with stations. 0, 1. Yes, there is, because there's 2 stations here. So the rest of the corners should only have 1. The rest of the sectors. 2, 0. 1. Yeah. Warp 3, 0. Yeah, 1. Okay. That's what's happening there. No worries. That should be pretty... We gotta get rid of that. But otherwise, the placement that code is actually, I think, working, looks like. Probably a simple way we could verify that, but there you go. Yep. Good first pass. Let's commit it. Work in progress, though. Add a random station generation. So we cycle through all of the sectors. And we try to add station to it. Adding a station to it. Maybe 0-1 50-50 is too high. Maybe we should like lower the chances that a station could generate, but we can tweak that, I guess, in a moment. Okay, so next step, randomize the positions. Let's do that one. Okay, so let's see. First we need the valid empty positions in the sector. I think we have a function for that. Empty sector tiles. We don't need the tiles. Let me add enemies, render, build sector tiles. We don't. Unless it's in quadrant for some reason. We have a to-do here, so available space. We need to actually implement available space. I'm gonna add that to this file here. I'll leave that there so I don't have to deal with the noisy commit. Okay, so we have to implement that, but that means, well, we might as well go ahead and get in on that because we need to figure out what space is available in the sector anyway. That's all the quadrant tile stuff, render, build tiles, yeah. So let's go over to sector. Where did we put the sector record? Internal? We did. Okay. Okay. Well, we have at least one empty space. We just need empty spaces. Sector. We want a list of let's see, how do we want to do this? So we have in the sector the list of stars. So anything in there is excluded. We know the dimensions of the sector. So we could just take a list comprehension and just filter out all the positions of these things. I think that's pretty much what we could do. So let's use our record wildcard here to pull out the sector elements. Yeah, we'll get E, well, position, forward, plot coordinates. Yeah, and that's going to be in the... I always forget this for some reason. Brain fart on it. There, but anyways, the main part of it is that we have whatever that's going to be, that range. We have to filter out chords. So we need... It's going to be kind of somewhat... Yeah, that'll be fine. Data.list has, I think, the function we want in it for list set-like elements. Set-like operations. Set operations. List difference. Right. So we have hello world on the left. Set difference with LW. You get Hoord. Right, removes that. That. And basically that's what we want from ours. We'll have cohorts. No, actually, cohort filter. No, members, set membership. We just want membership. That's all we need. To the list membership. I think there's like Elm. What am I thinking? Want not chord Elm. Chord is not an element of sector list stars. Like that. Okay, so that's one. Also need, pull these over a little bit. Chord's not an element of the enemies. This one I think we will need to list enemies. Which is just element. We'll just talk. And stations. And we need to convert that to just the coordinates. I think we have a little function that will fill in that hole there. Sorry. No. It's... Where is it? It's in... LambdaTrek. Position. Position. Get position. That's right. And we'll just import it. Simulation, optimization. Probably even just turn that into math over that. There we go. And similar thing here. Okay, so then we just need the sector positions. And that silly thing I keep forgetting. That. So we have to go... Let's do that for sector coords. Uh, 14? It's 15 by 15, I believe. 15. So 16 is. And then not element. That's helpful. That. Sweet, back to green. Love it. Awesome. Awesome sauce. Okay, cool. So now that we have the empty sector coordinates, we can go back and get our doohickeys. Right over there. Maybe a little space. We could do that. And we wanted to use this for station positioning during generate. That's one. In place station. All right, so we just have to get those empty sectors, pick one, and then use it for the position of the station. So we could go, let's say, station position, X. Station pause. What? Like this. Gen pick. Random. And we will give the empty sector coordinates here. So in order to do that, we need the sector from the quadrant. Quadrant stations. Generate quadrant. Not on it yet. And gen pick random. We're going to that's the map. So the sector stations would that be station map. Bang. The sector chord. Okay, and now that's the station list. No, wait. This doesn't seem right. What's going on? Why is my spider sense tingling? Let's go back over to quadrants. Sector internal. Okay, we do have to give the sector for empty cores. We don't need a specific station map. Actually, we're going to get the whole sector. We have a function for that. It's in station. No, it's in sector. This is our like little projection kind of function. Construct a valid sector from this data. And I think actually in quadrant, we wrap that. Get sector. Super duper. So, we just need quadrants. Then we need get sector, quadrant, sector chord. Now we can do our available space thingy. Internal, empty chords. In sector. Quadrant is not a function. Was it? It's generation quadrant. That's what I'm gonna have to. There we go. And gen pick random. That empty cores is just not in scope. Let's export it from here. Let's go back up to the top level sector module. Let's have it here. Ports. And we need to import vector. Okay, so then we just need to implement genpick random. That's a helper. No problem. We're good for time. Alright, so we're going to get a list of things. And in the state, generation state, we're going to return one of those things. Except if you give us the empty list. We're going to have to return maybe okay, and let's see. We need to get an index into our list. And a mix. That will be our gen random between 0 and length of list plus 1. Length of list. We should test this out. But length of X, I'm going to go with that for now. And that will get a random pair index. Then we basically don't forget to handle the empty case. And then, yeah, we do our good old handy-dandy list indexing. Bang, bang. So our element will be out of X's. And we could do pure just. How's that function? Bang bang list first. X's bang bang random mix. So genpick random, now we have to handle that case. Let's just call this maybe position. Could be technically impossible. Station X, station Y. Use station X and station Y, no problem. Use those here, station Y. Okay. Everybody's happy except for sector. Because it's shadows. Let's get rid of that then. Cool. Ooh. That's no good. Let's clean that up. Yeah, gen random. Boop, boop, boop. Boop, boop. We didn't need this. We don't need that. All right, we're back to green again. Let's check it out. Bang. All right, we do have a starting station here. And we do have one station here. So that does mean we are getting stations. Hard-coded still, because they're all in the same position. So we have to take care of that. 2-0. Let's see if we can find the Dubu station. Ooh. 3-1. Single station. 3-1. Single station. Do we even place one? Ooh, it's got to be on the other half. 0-2. Still. There we go. Double station. Boom. Okay. So that's good. Let's commit that. Add station placement. That's a work in progress as well. Place the stations during gen in empty space. And then we just have to get rid of the hard-coded station positions, which I think is going to be pretty straightforward. That's going to be Bing Bing up in game state, probably. I bet that's probably where I did it. State. Or maybe the default quadrant map. Yeah, there it is. Like that. Empty. Should actually, while we're here, make that empty as well. Yeah. This could be empty. We generate it all now. Don't need it anymore. Oh, wait a second, we messed something up here. Let's see. This might just be our test setup code relying on that version of init quadrant. So what I'm going to do is Simply going to get rid of these changes. Go back into quadrant. Take the init quadrant definition we have. And I'm going to go to our test module. And I'm going to put that here as init test quadrant. Then replace any init quadrants in the test module with test quadrant. That should be green, and now we should be able to go back and make that change, hopefully. As long as I'm not done. Kind of dumb. 41. Why am I dumb? Why is this dumb? Something's demanding this to be something it's not. Yep, I'm done. And a test quadrant. We do call in a quadrant in a couple places. Fourteen. Modify it there, then it'd be ships. Oh, is that like just an in-name problem? Have the wrong things imported, maybe? Could be. Okay, sorry, that was a quick diversion. This should be green. There we go. Okay, so now all the tests passed still. Now we can go into quadrant, change this init quadrant to be list. List. Okay, so my theory was not right about that. That's weird, though. They must be using... It must be using some other way of constructing the... Oh, no. Let's see. Hopefully we have enough time on stream to fix this, and then call it a night. So update simulation is basically the ID function. There's no command. Yeah. Initial game state gen. Is init games initial game state. Maybe that's constructing using... That's probably what it is. Initial game state's probably initializing using our modified one, which is breaking things. Yeah. Okay. That's using the generated quadrant. That could be it. Those tests expect a static preset quadrant, not a generated one. Okay. So we need the same pattern here. Spec. Boom. Initial test, game state. Bang, bang. Quadrant. We won't do generate quadrant. What we'll do for standard generator. We need to get rid of that. Standard gen's gotta be something. But this quadrant here can just be init quadrant, init test quadrant. 0, 0. And then we just become a standard gen. System.random has a couple of ways to construct these. Let's see if we can find a pure deterministic one. Buck standard gen with a determined number. That sounds good. I'll just pass this in, actually. Wait, I'm editing state. That's not what I want to edit. I'm going over here. Gen is passed in. Beginning state. So these all create their standard generator here at 0. Yeah. We could probably clean that up, but that means we don't have to handle this. We can just return game state. And just put gen here. And then we replace string initial game state with initial test game state. And does survey say that we passed? It does. Super. Let's just give it a quick whirl. Oh. No. Okay. Oh. Give me keys on an element map. What is causing that? Let's see. So we just... Let's stash this change. So I'm pretty sure that wasn't there before. We just emptied the lists here. Station, enemy ship map, star map. We kind of had some preset stuff. Maybe... Now, before we do this, let's jump back over to that. It was going too fast here. In a quadrant. This is all here. Where's the game called in a quadrant? So it's defined there. Simulate, generate. Here. That's it? I guess so. That must mean that somewhere in here we're throwing that exception. I'm expecting there to be some data already. Let's see. We use map.bang, I think, in this map. No bangs in this module. It is a map.bang. Let's find it. Grab that one, the literal. Escape it. No. Okay. Oh, that's super not helpful. We don't even use that indexing operator in this module. Although I don't think Swiper's picking up that too. We gotta be in here. Traversing enemies. Sector star. Okay, we're gonna stash this. Rebuild. Let's see if that changes what introduces this bug. Okay, it's got an index out of range on that one. So I think that's just our rand problem. I think the indexes were a little too high on that. So this generated fine though. So it is something to do with the init quadrant function. Okay. Gotta be. Tracking that down's gonna be tricky. The first thing I want to do is just quickly sector, internal, change the indices here, 0 to 14. Okay. And now we get that. Okay. It's gotta be in there somewhere. Generate. In a quadrant. Let's check generate stars. Random between 0 and 5. We traverse. Just generating random numbers to place stars in. We add sector star. That could possibly be a hiding one. Check add sector star. So we call add star on sector chord, star chords. Still no map lookup here. That could be an add star. So we go over to that. Well, we only use an adjust. No map indexing there. Either in add enemy or add station. Get sector does use it. Okay, let's go back over the generator. So probably not add sector star. Generate enemy ships. It must be their station's code, because I do call station place station. We did have to call get sector here, and this does go into a function that calls these. Let's see, so for this sector coordinate, we might not have added it yet, maybe. We generate quadrant stars. That's right. That's what's happening. Okay, I figured it out. So we need the that's the change. Yeah. Okay. So it makes a whole lot of sense now. If we go back to init quadrant, we change it to the empty lists. Map from list, empty list. And that means the map is empty. We want to actually not do that. We want to fill the map with all of the sector coordinates and just the sector data is empty. So, quick fix for that now is go in here, get rid of this hunk, and then go back into quadrant, Alright, we still want chord, we just want the empty list in there. Like that. We still want the chord here. We just want the empty list in there. Still want the chords for these. The empty list. Make sure it actually break anything. That's the... broke something by accident. Oh, it's using this comprehension. This is the empty list here. And I'm just going to make this look a little bit like the others so that it's just consistent. Okay. There we go. Just gonna need a little thinking, a little thinky doodle. Let's get to the end of the stream, which is where I usually start to get a little funny in the head. There we go. Problem solved. Okay, so we did generate a station here, but it's in a different position now, so that was randomly generated. We tried warping to 1-1. There is no station here. Oh. Right on. We tried a long-range scan at 0-1 and we find no station. Can't reach that far with our long-range scanners. No station there. LRS 10. 1 or 2 0. Yeah, should be. Oh. So there you go. Hopefully we find it somewhere. There, no, no, oh! 2 3. Sorry, 3 2. Okay. Warp 3. 1 3. Nope. 0 3. There it is. There's the other station we developed. So there's two stations randomly on the map, and in those quadrants, and nowhere else. That's awesome. Cool. So let's clean this all up, or at least as much as we can, because we're running out of time on the stream today. Boom, boom, boom. No staged. Let's whip. Fix up quadrant initialization. Whatever. Yeah, we can drop that stash. Okay. And let's squash. Let's rebase up to here. Squash those down. Reword that. Oh. Now it looks like we knew what we're doing the whole time. One nice little clean commit. Happy little commit. And push that up. Okay, so if this is your first time tuning in, thanks for watching and hanging out with me and chilling. All the code you saw for the project tonight, this is LambdaTrek, by the way, is up here on GitHub. I'm Agent Ultra. This is my GitHub here. You can find LambdaTrek here. And yeah, so if you ever want to check it out, there you go. And if you want to follow me on the socials, I'm on the Tutorverse? Mastodon. I'm on the Tights.pl server there. If you follow the link above, there's a cool Discord server. That Discord server, or there's a link to a Discord server, and the Discord server there has a channel for this stream. So if you want to like chat between streams, if you're catching this in a different time zone, you're watching my YouTube channel, which is on my Mastodon profile, you can chat with me there, and we'll hang out. It'll be great. Let's see what else. I usually do these streams once a week on Tuesday evenings at about 10 after 8 in the Eastern Daylight Time Zone we're in right now. I don't know. It's super dark out, and I wish it wasn't. But if you want. You could also, you know, subscribe here on the Twitchers and get the notifications when you subscribe to the channel and all that. Great. And then you get notifications if you have your notifications turned on when I go live. Sometimes, occasionally, I do surprise streams here and there of just random stuff. You never know. And of course, if you're on the YouTubes there watching the stream there, then you know what to do there. So like, subscribe, and whatever. It doesn't matter a whole lot these days, but there you go. Yeah, so there you go. Thanks for tuning in again. I'm Agent Ultra. It's been a pleasure. May your monads be free and your types always check. We'll see you next week. Peace out.